Thank you, Hans. Hi everyone. My name is Tom. I work at Ecofis as a consultant in our energy policies and strategies team in Utrecht. My colleague Maurice Schaefer is also here with me. He's a managing consultant working from the Berlin office. And we were asked by the Copper Institute to prepare a briefing based on a study we did for them on EEO schemes recently. And we are, of course, happy to do that. So in this briefing, I'll quickly go into energy efficiency obligation schemes, what their role is in the Energy Efficiency Directive, and also what some of the challenges are when it comes to stimulating certain technologies under EEO schemes. So the outline of the presentation is as follows. First, I'll talk about some of the basics of EEO schemes. Then I'll give some country-specific examples on how the EEO schemes work there. Then I'll go into how the cost effectiveness of different energy efficiency measures is typically determined. Then I'll go into which technologies are usually incentivized under EEO schemes, and also which technologies could then do well under an EEO scheme, which are currently not stimulated. And finally, some main takeaways in the conclusions. So, the current situation. So essentially, the EU has an indicative 2020 energy savings target. That's unlike the 2020 targets for climate change and renewable energy, which are then binding for the different member states. And this is then translated by member states into their own national energy efficiency target, which the European Commission will then approve or not, depending on whether this is enough to actually reach that overall EU target. And finally, Article 7 of the EED also sets a general binding target to deliver that 1.5% cumulative annual end-use savings, which over the period of 2014 to 2020 should deliver at least 10.5% cumulative end-use energy savings. And these targets under the EED can then either be achieved by putting in place energy efficiency obligation scheme or alternative measures, or both, of course. Now, one of the proposals by the European Commission in the winter package last year is that the energy efficiency target for 2030 is increased from 27% to 30%, and is also made binding instead of indicative. And besides that, they also propose to extend the 1.5% energy savings obligation towards until 2030, which will also need to include mandatory measures to combat energy poverty, for example. And there's also a new clause saying that self-consumption of renewable energy can now be excluded from the target, which would then lower the absolute target. So how do these EEO schemes work in essence? Well, first of all, it's I think important to realize that not all EEO schemes are the same, and they can differ significantly between the different member states. But essentially, every time there's a public authority that sets a target, in line with the overall policy objectives of that for the EEO scheme, and that target then gets shared by the different obligated parties that are assigned. And these are selected. These are the parties that are selected to meet the target. And often these parties are DSOs, energy suppliers, or energy utilities, for example. But at least it's important that these obligated parties are entities that have a really good relationship or a connection with the end users that need to reduce their energy consumption. And then these obligated parties can choose themselves which approach they want to use to attain the target. And we will go into some of these specific examples later on, but essentially these obligated parties can choose to use a market-based approach or a trading system with energy efficiency certificates, or they could give financial incentives through, for example, subsidies or tax breaks. And lastly, also the sector that is chosen is, or the sector that is targeted is chosen. So you can choose, for example, if you want to choose or target industries or mainly the residential sector of all sectors. And And yeah, the scheme design is often done in a way as well whereby existing policy instruments are used as much as possible. So what you then see is that naturally that results in every country that has an EEO scheme having different features in their schemes. So on the next slide here, we have an overview of countries that currently use EEO schemes or have ones currently planned. Now you can see that multiple countries currently have a scheme planned, but countries like France, Ireland, the UK, Italy, and Denmark have had EEO schemes for quite a while, and Poland recently introduced theirs a few years ago. And I'll give you some examples of how these schemes look like in some of these countries. For example, in the UK, or in this case, it's actually rather Great Britain, because in Northern Ireland is a bit different. But there's a main focus on combating energy poverty. So under the scheme, mainly insulation measures are supported. And also for vulnerable customers, the range of measures is somewhat extended. And this is a good example of a scheme that really works well together with other policy measures that exist, because it supports consumers that would not be eligible for a loan scheme under the Green Deal policy the UK has. So if the return on investment on a certain measure is lower than the interest rate under a loan grant, then they can apply for this scheme. So a specific choice of the UK was here to really target residential electricity and gas consumers. But the only reason they give for this is that there is a risk of cross-subsidy between the households and the business sector. But that has not really been proven to be a significant issue in other countries. So that's really generally thought of as not to be a very convincing reason to restrict the scheme to only these residential consumers. And also the focus here is really on insulation measures, which could really lead to underfunding measures in lighting and appliances. Then there's the Danish EEO scheme, which has been very successful. Obligated parties really exceeded the targets that were set, and also part of the reason here might be that consumers can choose to apply for funding for any measure that is deemed cost-effective. And the obligated parties are mainly grid distribution companies and have really targets for all sectors, so also industry and transport, which is not very common among member states. And the main instrument for incentivization is providing advice on energy efficiency measures and also providing subsidies. So it's relatively a straightforward approach compared to other more complex schemes. Then there's Italy, which is quite different from the previously mentioned examples in that it was really the first scheme that introduced white certificates in 2004. So it's called the White Certificate Scheme. And they managed to achieve 60% of their national target through the scheme. So that's also quite a significant achievement. And what these white certificates do essentially is that they represent marketable documents. They're basically equal to 1 ton of oil equivalent that can be exchanged through customers via contracts. And the prices of such certificates then range from about 90 to 100 euros. Also interesting about this scheme is that more than any other scheme, industrial consumers kind of dominate the certificate market by making around 90% of all the white certificates. So what I tried to tell you with these examples is that EEO schemes can be very diverse in terms of incentives, sectors that are targeted, and also the main policy aim, and also that it's difficult to state conclusions that count for all EEO schemes, but I'll try to do so. I'll go through these slides relatively quickly due to time considerations as well, but the main message here is that ideally you would want to assess all measures based on the levelized cost of energy efficiency, where you would calculate the annual lifetime cost per unit of energy saved. But often what you see is that data is lacking to actually do this, and also all countries assess the cost effectiveness of their measures in a significantly different way, which is shown on this slide. For example, if we look at Italy, they calculate this as a ratio between the discounted incentive and the capital cost of the measure, whereas Denmark calculates the effectiveness of the scheme as a whole and compares this then to other energy efficiency policies. What we also see is that there's really a risk of trying to make such a comparison between countries and the effectiveness of schemes is that because these EEO schemes are so different, you might end up having a kind of skewed picture because this cost effectiveness figure is very much influenced by which consumers are targeted, how easily energy savings are achieved here, and also where a country stands at this stage, of course, in its achieving energy efficiency. But in general, we can say that for all countries that have EEO schemes, the energy savings that are achieved are generally cheaper than the costs of energy production, but have at the same time also increased energy costs for households, since the consumers are the ones really financing the scheme. Also interesting to see is which technologies are generally targeted through the different EEO schemes, and also how these technologies are generally selected or chosen by the consumers. And the European Commission itself states that the main driver for EEOs is to deploy the proven technology or the proven energy efficiency measures that are currently not happening at the rate that would be expected from economically rational behavior. So this really shows that often the measures that are targeted are cost efficient in the long run and are low-hanging fruits in terms of energy savings. So in principle, breakthrough technologies could also be financed, but a lot of countries work with these so-called catalogs of measures which have verified final energy savings, and the main criteria for inclusion in such lists is that the measures should be additional, that they need verified deemed energy savings, and also no conflicts in the primary policy objectives should exist. So what that means is if there's already a policy in place that aims to increase renewable energy deployment, for example, and has incentives in place to do this, then financing, for example, a solar thermal boiler through an EEO scheme would be more difficult. Now, these eligibility lists may sound as if they could really hinder technology deployment, but in practice, it's rather a matter of verifying the energy savings that are achieved with that measure and also documenting it. And some schemes use a somewhat different approach and accept any measure that has energy savings and calculate the energy savings on a case-by-case basis. So Austria is, for example, a good example of they have a scheme planned that does it in that way. And in practice, there are several criteria one can think of that contribute to the penetration of a certain technology under an EEO scheme, such as the measurability of the achieved energy savings, the cost efficiency of a technology, and also the potential final energy savings that can be achieved through that technology. And in this case, the first criterion, so the measurability, is more or less, the obligated parties are more or less responsible for that to facilitate, because the right methodology needs to be in place to verify the energy savings. Other approaches exist as well to get measures stimulated under an EEO scheme. If we look at Italy, for example, they changed energy efficiency parameters related to the technology lifetime, in which the case of Italy was it's called the tau efficient, and that's a multiplier that takes into account not only the yearly savings for the first 5 years of the project, but also the savings related to the technical lifetime, and that really helped surge measures in the industrial sector. So to the final section of my presentation already. So what we aimed to do here was really painting a rough picture of which technologies we have a chance of doing well under an EEO scheme and that are currently not included in EEO schemes. And that was done by applying benchmarks. So for example, lower than 10% final energy savings would be red, and higher than 30% would be green. And in doing this, we identified that if we look at residential measures, building automation systems, for example, on average have a high potential of achieving final energy savings, and that there's a good return on investment, but that these savings are very difficult to measure and to verify by the administrative bodies. So this could flourish well under if the obligated parties facilitate this. We also see that electric vehicles are subject to quite some baseline issues, and also often conflict with other policy objectives that are in place in that country, and also the associated financing with that. But they could be successful under an EEO scheme that considers transport measures, such as the one in Denmark, but only if such methodological issues are resolved by these obligated parties. As for the non-residential technologies, for example, in industries, we identified that fuel switching in furnaces to electricity, for example, can lead to significant final energy savings, but the cost efficiency of such measures is generally low due to the high capital cost investments. But if obligated parties would choose to finance these type of measures, and they would facilitate also the methodological approach to calculating the final energy savings for this measure, we think that the uptake under EEOs could potentially increase this technology. And in countries such as Italy, which is a large facilitator of white certificates in the steel industry, would be a right country for that, for example. Finally, we see that investments in power cables are generally very cost efficient, although really resulting in quite little final energy savings. In practice, they are not covered by any EEO scheme, but might really do well if it is made more of a priority by countries as obligated parties. So what we can conclude from this in general is that in principle, all energy efficiency technologies under EEOs are subject to that technology market principle, and also the willingness of consumers to implement them, which is generally determined by the cost efficiency of a measure and the final energy savings that are achieved. But before that, so a prerequisite of that is that methods for calculating these deemed energy savings are in place, developed by the obligated parties, which is the task of that obligated party in that respective member state. And when it comes to the specific technologies that could deserve more attention, we identified, based on these criteria, that furnace fuel switching and power cable replacements could do well under an EEO scheme that targets industrial consumers, such as Italy and Denmark, and that building automation systems and electric vehicles could do well or work well if a number of methodological challenges are resolved, and also if transport is targeted by that specific scheme. Finally, we can confirm that EEOs are specifically suitable for the really low-hanging fruit technologies, and generally become less effective when markets are saturated with that technology. And stimulating innovative breakthrough technologies is probably best done through additional policies, and is not suitable with EEO schemes if quick deployment is desired. Thank you.